experiment, a golf ball and a ping pong ball are dropped in water. Look to see which one creates a bigger splash. Because Newton's second law, that acceleration is equal to net force divided by mass, rearranged so that net force is equal to mass times acceleration, with acceleration constant about 9.8 meters per second squared. The more massive golf ball will create a bigger splash than the ping pong ball.
In the following experiment, a Nerf gun will be fired and the bullet will impact either the lacrosse ball or the ping pong ball in separate trials. Look to see which produces the greater effect, assuming the force of the Nerf bullet is equal on both balls. Clearly, the ping pong ball experienced a much greater acceleration than the lacrosse ball. This can be attributed to Newton's second law. Newton's second law states that acceleration is equal to F net over mass. The mass of the lacrosse ball, being greater than the mass of the ping pong ball, caused it to have less acceleration, assuming that the force of the bullet was constant. The relationship between acceleration and mass is an inverse one. So the more mass that an object has, the less acceleration that will be produced due to an equal force.
In the next experiment, a car is pulled with 0.5 newtons of force and 5.5 newtons of force on a nearly frictionless surface. Because net force is equal to mass times acceleration, the 0.5 Newton weight and the 5.5 Newton weight pull the car differently. Because the mass of the car is constant, if the force increases, the acceleration increases. So if the acceleration increases, so does the time it takes to go to the end decreases. So that's why the heavier weight pulls the car quicker than the lighter